Hello all, this is Uma, Assistant Professor from the Department of Biochemistry, MGR College, Hosur. Today we are gonna see about column chromatography. So before that, what is a chromatography? A chromatography is an important biophysical technique that, that enables the separation, identification and purification of the components of a mixture for quantitative and qualitative analysis. Chromatography is a separation technique in which a mobile phase carrying a mixture is caused to move in contact with selectively absorbent stationary phases. There are different types of chromatography. In that, we are going to see about column chromatography. So, column chromatography. It is a technique in which the substances to be separated are introduced onto the top of a column packed with an absorbent passed to the column at different rates that depend on the affinity of each substance. The absorbent for the solvent and a solvent mixture are usually collected in a solution as they pass from the column at different times. It is a solid liquid technique in which the stationary phase is a solid and the mobile phase is a liquid or a gas. Usually, the chromatography that consists of the two phases, a stationary phase and a mobile phase. Here, the principle of the column chromatography. In column chromatography, the stationary phase, which is packed into a glass or a metal column. Here, the column, what is you know about the column? The column is nothing but it is like a bearing shape and made up of glass or a polyacrylic plastic, a cylindrical shaped column. But it doesn't contain any readings. In column chromatography, the stationary phase is packed into a glass or a metal column. The mixture of analytes is then applied and the mobile phase is commonly referred to as the elutes. So these passes through the column either by the use of the pumping system or by applying a gas pressure. As the elute flows through the column, the analytes are separate on the basis of their distribution coefficients and also emerge individually in the elutes as it leaves the column. So the instrumentation of the column chromatography. So a column chromatography system using gas or liquid mobile phase consists of the following components. They are of a column, a stationary phase, a mobile phase and delivery system, an injector system, a detector and a chart recorder, a fraction collector. A column. So as I said before, a column is nothing but a burette shaped glass or a plastical cylindrical column without any readings. And in liquid chromatography, these are gradually of 25 to 50 centimeter long and 4 millimeter of internal diameter. And it is also made up of stainless steels, whereas in gas chromatography, they are of 1 to 3 meter long and 2 to 4 millimeter internal diameter and are made of either glass or stainless steels. They may be either of the conventional type filled with the stationary phases. So here the stationary phases which I have mentioned is of the polar solid materials which is packed into a vertical column. So as I said before, it is like a burette shape. So the polar solid materials are packed in a vertical column that is made up of a glass or metal. Here the stationary phases we are filling of the solid polar materials are like cellulose, dextrose, agarose, etc. So it may be also a microbore type in which the stationary phase is coated directly on the inside wall of the column. A stationary phase that can be chosen to be an appropriate for the analytes to be separated, and a mobile phase and a delivery system chosen to the complement the stationary phase and hence to discriminate between the sample analytes and to deliver a constant rate of flow into the column. An injector in which it is used to deliver the test samples to the top of the column in a reproducible manner. And the detector and the charge recorder in which it gives a continuous record of the presence of the analytes in the elutes as it emerges from the column. And the detection is usually based on the measurement of the physical parameters such as a visible or ultra visible absorbance or fluorescence. And the chart recorder in which a peak of on the chart recorder represents each separated analytes, and a fraction collector is for collecting the separate analytes from for the further biochemical studies. So here the fraction collector collects the elution for the further final results. Next, the steps in column chromatography. Here it consists of the four steps: the preparation of the column, introduction of the sample, elution, and the detection of the components. Firstly, the preparation of the column. The column in which it is mostly consists of glass tube packed with suitable stationary phases. Before the column here, as I said before, the column is like a burette shaped. It may be a metal, a glass, or a plastic. A glass wool or a cotton wool or a cotton pad is placed at the bottom of the column before packing the stationary phases. Here the stationary phase is filled, which I have already said that it may be cellulose, dextrose, agarose, etc. It is based on the uh, sample we are using, and the analyte it is based on the analytes. After packing, a paper disc should be kept on the top so that the stationary layer is not disturbed during the introduction of the sample or a mobile phase. Here the mobile phase is nothing but the liquid or gas which we are using here. The mobile phase in liquid may be mostly of solvents we are using, and there are two types of preparing the columns. They are of dry packing or dry filling, and wet packing or wet filling. In dry packing, in this the required quantity of adsorbent is poured as fine dry powder in the column, and the solvent is allowed to flow through the column till equilibrium is reached. While in wet packing, the slurry of adsorbent with the mobile phase is prepared and is poured into the column. It is considered as the ideal technique for packing. So before using this column, it should be washed properly and dried. The column should also be free from impurities uh, and uniformly filled with the stationary phases. Next, the introduction of the sample. The sample, which is usually a mixture of a component, is dissolved and minimum quantity of the mobile phases. The entire sample is introduced into the column at once and get absorbed on the top portion of the column. In here, we can't refill or reload the samples again and again. The entire sample should be introduced into the column at once. And from this zone, the individual samples can be separated by a process of elution. So the elution is nothing but after adding the mobile phase, the solvent or a gas, it travels through the stationary phases. It starts moving along with the sample, and finally we'll get an elution which is collected in the fraction containers. The elution. The elution is of further, it is in two techniques. It is of isocritic elution technique and the gradient elution technique. In isocritic elution technique, um, the same solvents that of as composition or solvent of same polarity is used throughout the process of the separation. For example, we can say that the use of the chloroform, alone or ethanol alone. We use only one solvent for the entire collection of the elution. Whereas in the gradient elution technique, solvents of gradually increased polarity or increase in elution strength are used. During this process of separation, we can use literally we can say that we can use more than two, three, or four solvents in this technique. But while it's an isocritic technique, we can only use only one solution again and again. But in gradient elution technique, we can use more types of solvents, but it is based on its polarity, starting from lower polarity to the higher polarity. For example, we can say initially benzene, then chloroform, then ethyl acetate. So it is based on the polarity of the solvents which we are using. And the detection of the components, if the components are separated in a column chromatography procedure, they are colored. If they are colored, the process of the separation can simply be monitored visually. The components to be isolated from column chromatography are colorless. In this case, small fractions of the elute are collected sequentially in label tubes. See, here we have already collected the elutions in the fraction collectors containers, right? We can label the containers, and in this case, small fractions of elutions can be collected, and each composition of each fraction is analyzed. That can also be analyzed by the technique of TLC, which is of thin layer chromatography. If the components isolated are colorless, we go for such techniques. And there are also some of the factors that affects the column efficiency, and some factors affecting the column efficiency that may say that may based on the dimensions of the column or the particle size of the adsorbent or the nature of the solvent which we are using, and the temperature of the column and the pressure. Here you can see that after loading the sample, we are loading the mobile phase, which is of the solvent here. It gradually moves, it travels, and along with the sample which have placed, which have loaded, and the weaker interaction that travels faster, and the stronger interaction moves slowly. And finally, we get the eluted molecules in the fraction containers. And next, the applications and advantages of the column chromatography. There are in column chromatography is one of the most useful methods for the separation and purification of both solids and liquids. Its major application also includes the separation of the mixture of the components, or else the removal of the impurities, or it is also used in the purification processes. The column chromatography is also used in the isolation of the active constituents and also the metabolites from the biological fluids. It is mostly used in the estimation of the drugs in formulation or crude extractions. So it also have some of the advantages in it. So any type of the mixtures that can be separated by the column chromatography, and any quantity of the mixture can also be separated. The quantity can be lower or larger. The wider choice of the mobile phases, and in the preparative type, the sample can be separated, and also it can be reused. And the column chromatography is also possible in automation method. And that's all. Thank you. We'll meet in next video.